Find the acceleration within the first 5 seconds. Find the acceleration within the first 5 seconds. So first 5 seconds from 0, 5 seconds is here. So they're talking about this part here. What was the acceleration? So acceleration, it's v minus u over t. Okay, what's the v? The v is the final speed here, which is 15, minus u. U is the initial speed here, which is 0 over time from here to here. It's 5 seconds, the first 5 seconds. So it's 15 over 5, which is 3. 15 divided by 5 is 3 meters per second squared. Okay. B, find the deceleration in the last 2 seconds. So the last 2 seconds is from here to here. So they are talking about this. So deceleration, I'll just use the word DEC for deceleration because I don't have enough space. So the formula for deceleration, there are two. There is one which goes like this, negative v minus u over t. Or you can find the acceleration here, then you change its sign. Or my favorite is this, u minus v over t. Acceleration is v minus u, but deceleration is u minus v. Okay, so u is the initial speed or initial velocity, which is the velocity to speed here. In this case, 15. So it's 15 minus final velocity is the velocity here where the journey ends. In this case, if we go like this, it's okay, so it's 15 minus 0 over time is 2 seconds. Okay, so this is 15 minus 0 is 15 over 2. 15 over 2, it's 7.5. Okay, 7.5. Okay, you have to put the units, meters per second squared. So the final answer is going to be like this, 7.5 meters per second squared. Okay. So that's how to find the deceleration. We go to question C. Question C, find the distance covered in the first 10 seconds. So first 10 seconds is up to here. So what shape do we have here from here to here? Okay, so we have something like this, which is a trapezium. Okay, this is a trapezium. It has A from 0 to 10. So 10 minus 0, A is 10. Then B is from here to here. So B is 10 minus 5, it's 5. Okay. Then H is it's from here. Okay. Which is 15 and 0. Okay. So H is 15 minus 0, 15. So formula we use, we say distance is equal to area, which is equal to half A plus B H. Okay, so it's going to be half, what is our A? 10 plus our B, 15 times our height, 15. So I'll continue it on top. So it's going to be 10 plus 15 here is 25. So it's going to be distance is equal to half 25 times 15. Okay, so what can we do from here? Okay, so there are many ways to kill a rat, so you can use whichever approach, but you can know you can say, okay, 25 times 15 it's what? So on a rough paper you can do 25 times 15, 5 times 5, 25. Okay, so it's 5 carry 2, 5 times 2 it's 10 plus 2, 12. Okay, we put 0 here. 1 times 5, 5. 1 times 2, 2. Okay, so it's going to be 5, 2 plus 5, 7, 1 plus 2, 375. So it's going to be half times 375. Okay, half times 375. Okay, so here now, what is half times 375? So you can do 2 here cancels 2 into 3, it's 1, remainder 1. 2 into 17, it's 8, remainder 1. 2 into 15, it's 7, remainder 1. Okay, we can put a point and you put 0. 2 into 10, it's 5. So it's 187.5. Okay, that's the distance in the first 10 seconds. So I'm sure I've confused you because I made a mistake somewhere. So let me just redo it. Okay, but here we have A10, B5, and H15. Okay, so it's going to be distance is equal to area, so which is half A plus B H. So it's going to be half A, we said it's 10, plus B, it's 5, times H, which is 15. So it's going to be half 10 plus 5, 15, 15. So 15 times 15, it's going to be half times. So what is 15 times 15? So 15 times 15, if you did, if you mastered the squares of numbers from 1 to 20, then it should be easy. But if you did not, you can just do on a rough paper like this. So 5 times 5 is 25. 5 carry 2. 5 times 1 is 5 plus 2, 75. You put 0 here. 1 times 5, 5. 1 times 1, it's 1. So you add this 5 plus 0, 5. 7 plus 5, 2. Remainder 1. 1 plus 1, 2. So it's going to be 225. Okay, just in case you have not mastered it. But if you haven't, this is the time to master it. 15 times 15 is 225. Okay, these are common numbers that you'll be meeting, so it's advisable to master them. Okay, so this is 225. Okay, so half times 225, you can do 2 here, 1, 2 into 225. So you can start slowly. 2 into 2, it's 1. 2 into 2, it's 1. 2 into 5, it's 2. Remainder 1. So you put a point here, you put 0. 2 into 10, 5. So it's 112.5 meters. Then question D says, find the distance covered in the last 2 seconds. So the last 2 seconds are these. Okay, what shape is this? It's a triangle. So a formula for the triangle, its area is equal to half BH. Okay, so distance is equal to half BH. B, it's here, which is the difference between 12 and 10, which is 2. And H, it's here. Okay, so this is where height is, which is from 0 to 15, as you can see. So it's 15. Okay, so distance is going to be equal to half times 10 times 15. Okay, half times 10 times 15, which when you solve, you're going to get 75 meters. Okay, if you solve, you're going to get 75 meters. Okay, again, I've made a mistake because B, it's 2, not 10. So let me redo it. So distance is equal to half BH, right? So half B, it's 2 actually. Then H, it's 15. Okay, so 2 and 2 cancel. So we remain with 15 meters. We got question E. Find the average speed for the whole journey. So for you to find the average speed, you need to know the total distance over total time. Okay, so it's distance over time, but it should be total distance over total time. So what's the total distance? We have calculated the distance of this part of this. We've calculated its distance. Okay, we found that it is 112.5 meters. We have also calculated the distance for this part, which we found to be 15 meters. Therefore, total distance is equal to 112.5 plus 15. Okay, so 112.5 plus 15, which is equal to 117. Sorry, it's going to be equal to 127.5 meters. So this is the total distance, 127.5 meters. What about the total time? The total time, there's no need to calculate. It's just from here to here, which is 12. Okay, once you have the total distance and the total time, then you can say average speed is equal to total distance, which is 127.5 meters, over total time, which is 12 seconds. Okay, so when you divide this, you're going to get 10.62 meters per second. Okay, so we go to question 2. The diagram below shows the speed time graph of a vehicle that traveled from Chipulukusu to Kawama and covered 97.5 meters. Okay, so this journey, the whole journey, is 97.5 meters. Okay, find the value of t. Find the value of t. So there is no way they can give us this 97.5 just for nothing. Okay, they want to use it. They want us to use it to get something, and that something in this case may be t. So how do we find the value of t? Let's try to find the total distance of this shape. So distance is equal to area. Okay, so what shape is this? So this shape is like this, the whole shape. Okay, it's again the trapezium, where our A is from here to here, meaning t minus 0. So our A is t. Our B is from here to here, here to here. So it's from 10 to 5, which means our B is 5. Okay, our H is from here to here, meaning 15 minus 0. So our H is 15. Okay, our H is 15. So we can start calculating. But we know the distance is 97.5. So we're going to say distance is equal to half A plus B H. But we know what distance is. It's 97.5. Okay, which is equal to half. What's our A? Our A is T. What's our B? Our B is 5. What's our H? Our H is 15. Okay, so we start calculating. So how do we go about this one? Okay, if let me just remove everything so that it's clear. I'll start from here. Okay, so that you also learn how to manipulate here. Okay, so we have 97.5 equals 1 over 2 t plus 5, 15. Okay, so the first thing you can do is, if 15 was divisible by 2, you could have cancelled like this, but it's not. So if it's not, you can do cross multiply. Okay, you can do cross multiply. Okay, so in cross multiply, you multiply 2 by 97.5. Okay, so 2 times 5, it's going to be 10, 0, carry 1. 2 times 7, 14, plus 1, 15. So you write 5, carry 1. 2 times 9, 18, plus 1, 19. So it will give us 195. Okay, so in fast forward, 2 times 97.5, it's 195. Here we remain with t plus 5, 15. Okay, if you want, you can multiply on a rough piece of paper. You get 195. From here, there are two things we can do. We can divide both sides by 15, and that can be okay if 195 is divisible by 15. That is, if 15 goes into 195. Or we can expand here so that we have 195 t times 15, 15t, plus 5 times 15. Okay, what is 5 times 15? It's 75. Okay, then we can bring 75 this side, so it becomes 195 minus 75 equals 15t. Okay, so 195 minus 175, 195 minus 75, it's 120 equals 15t. So we can divide both sides by 15 by 15. Okay, so 120 divided by 15, it's you can do 5 into 15, 3, 5 into into 12, it's 2, remainder 2. 5 into 20, it's 4. Okay, again 3 here, 1. 3 into 24, it's 8. So here we remain with 8. Here they'll cancel. So our time is 8 seconds. That's what our T is. So don't think they can just give you this number and they don't expect you to use it. Question B, find the average speed. Average speed, it's simple. We know it's total distance over total time. What is the total distance? The total distance is 97.5 we're given, okay? Over total time from 0 to 8. But how come time is 8 when, oh, I think this 10 here was a mistake. It's not supposed to be here. Okay, so the question that I have, it has a mistake because the total time is 8 seconds. Okay, so 97.5 divided by 8. So you can manipulate. You're going to get how do you simplify this further? Okay, so let me just do this. So it's 97.5 over 8. So to remove the point, you can multiply both sides by 10 by 10. So when you want to remove the point, you multiply by 1. The number of zeros that 1 is going to have is just the same as the number of digits that are on the right side of the point. In this case, there is 1 digit. So we multiply with 1 and 0. Okay, 97.5 times 10 is going to be 975. Okay, 8 times 10 is going to be 80. Then we start 8 into 97, it's 1. Okay, 80 into 97, it's 1. Remainder 17. Okay, 80 into 175, it's 2. Okay, so 8 into 175, it's 80. Another 80, which gives us 160. So 175 minus 116, 160 will remain with 15. Okay, so 8 into 15, it can't. So you put a point here, then you can put 0 here. 8 into 150, it's ones. Okay, it's going to go there once. Okay, remainder, so 150 minus 80, it's 70. So remainder 70. Okay, maybe you can leave it here just one decimal place as 12.1. Okay, so I wanted to show you different, just how to struggle with such. So the final answer is 12.1 meters per second as the average speed. See, find the acceleration in the first 5 seconds. Acceleration, it's simple, it's v minus u over t. So final velocity, it's 15 minus initial velocity is 0. We're talking about here in the first 5 seconds. Time is 5 seconds. So 15 minus 0 is 15 over 5 seconds. 5 seconds into 15, 3 meters. Yes, 3 meters per second squared as the acceleration. 15 divided by 5. Question D. Find the speed it had at 2 seconds. So this one is now interesting. Find the speed it had at 2 seconds. Where is 2 seconds? 2 seconds somewhere here. We're not sure. So if we go up, we meet the graph here there. Okay, let me do it properly. We meet the graph there. If we go this side, the speed must be somewhere here, but we don't know. It has to be between 0 and 15, but we don't know that speed. So what can we do? So we know the acceleration here. So the acceleration here is said to be uniform acceleration, meaning that the acceleration here is the same. Okay, so if we can act as if we want to find the acceleration from 0 to 2 seconds, then we can use the same kind of analysis to find speed. So what I'm saying is, if we say acceleration is v minus u over t, okay, so acceleration, we are from calculating, we have found acceleration to be 3 meters 3 meters per second. Acceleration, we had found 3 meters per second. Okay, yes, we had found 3 meters per second. So acceleration, we know that it's 3 meters per second, okay, squared between here, and here. Okay, so here the acceleration is also 3 meters per second squared. Okay, that's how it works. Okay, so in a nutshell, the acceleration here is the same as the acceleration here, which is the same as the acceleration there. Okay, let me say that again. The acceleration here is the same. Okay, also the acceleration here is the same. Also the acceleration here is the same. Okay, this and this and these are different accelerations, but on this line at whatever point here is the same, and at whatever point here is the same, just like here. So if here is 2 meters per second, then here it's also 2 meters per second, then here also is 2 meters per second. And if here it's 4 meters per second, though here it's always 0, so mean that even here it's 0, even here it's 0. Then if here it's negative 2 meters per second, here it's negative 2 meters per second, here it's negative 2 meters per second. So that's the idea here. Okay, so now we want to find the acceleration from 0 to 2 seconds. So the final velocity at 2 seconds, we don't know it, but the initial velocity, we know it's 0. Okay, then time, it's 2 seconds. So we solve for v. Okay, so I'm going to continue it from here. So it's going to be 3 v minus 0 v over 2. So we can cross multiply. So it's going to be v times 1 v, 3 times 2, 6 meters per second. So this is the speed at 2 seconds. Going to the next question. Okay, so here they are saying if the acceleration in the last 5 seconds was 1 meters per second, find the value of v. If the acceleration was 1 second, was 1 meters per second, find the value of v. So in the last 5 seconds, it's here. Okay, so like I said from the previous question, this acceleration here is the same. Okay, so we're looking at question 3 now. Okay, so they want us to find the value of v here. Okay, so we're going to act as if we want to find acceleration. So we're going to say acceleration is equal to v minus u over t. So acceleration they have given us, it's 1, because what's the final velocity? We don't know. It's v minus initial velocity. It started from here, so here the initial velocity is 10. Okay, so it's going to be 10 over time from here to here, it's 5. Okay, so it's going to be 1 is equal to v minus 10 over 5. Okay, so v minus 10 over 5. So how do we solve this? We can cross multiply. 1 times 5, 5. 1 times v minus 10 is v minus 10. So when negative 10 goes this side, it becomes 5 plus 10. Okay, v. 5 plus 10 is 15 meters per second. That is v. Okay, we go to question B. Okay, find the time it attained a speed of 12 meters per second. So they want us to find the time it attained a speed of 12 meters per second. We can tell that this is 10 and this is 15. So 12 must be somewhere here. So what time, if we go to the graph, okay, if we go down here, time must be between 10 to 15. But what is that time? How can we find the time? We use the same principle of acceleration. We try to find acceleration from here to here. Okay, but we know the acceleration because the acceleration is the same here. So the acceleration is 1. So acceleration is equal to v minus u over t. So acceleration is 1. Okay, final velocity, here they have said at this point, they have said at 12 seconds, 12 meters per second. So it's 12 minus initial velocity. Initial velocity we know here it's 10. Okay, minus 10. Okay, over time. Time, we don't know the time, so we're going to call it t. Okay, we don't know the time, so we're going to call it t. So t minus 10, the difference between the time we're looking for and 10 is the time these things happened here. Okay, so it's going to be t minus 10. Okay, so we can do cross, before we can do cross multiply, we can say 1 is equal to 12 minus 10, it's 2 over t minus 10. Okay, so here we can do cross multiply where we say 1 times 2. So we're going to do it on top. 1 times 2 is 2 equals 1 times t minus 10 is t minus 10. So we can take negative 10 this side. It's going to be 2 plus 10 equals t. 2 plus 10, 12 seconds equals t. So time is 12 seconds. So between 10 and 15, it was 12 seconds when the speed was also 12 meters per second. Question C, find the total distance covered. Total distance, we need first to identify the shape. So the first shape I can see is this, okay, which is a trapezium. I can also see this, which is also a trapezium. So for the first shape, I can say my A is from here to here. 10 minus 0, it's 10. My B is from here to here. 10 minus 5, it's 5. And my height is from here to here, which if we go this side, we can see that it's 10 and it's 0. So 10 minus 0, it's 10. So I can say distance is equal to area under the graph. Then area, it's half A plus B H, which is going to be half. What is our A? Our A is 10. What's our B? 5. Our height, 10. Okay, so this and this can cancel. I mean, 2 here and 2 here is 5. Okay, so we're going to have 10 plus 5, 15 times 5. 15 times 5, it's 75 meters. Okay, so the first shape, the distance is 75 meters. We go to the second shape. Okay, so the second shape is this. It's a trapezium that has been rotated. Okay, so it has been rotated. Can I rotate it? Okay, let me see if I can rotate it. So it's like this. Okay, so the same principle applies. Okay, A is from here to here, which in this case it's from our V, which is 15 minus 0, so it's 15. Our B, it's from here 10 to here 0. 10 minus 0, it's 10. Our height is from here to here. 15 minus 10, which is 5. So the numbers we're going to use is 10, 15, and 5. Okay, 10, 15, and 5. Okay, so let me just take it to the way it's supposed to be. Okay. Okay, so again, we write distance is equal to area. So distance is equal to half A plus B H. So it's half A. So A, we said it was 15 plus B. B, we said it was 10. And H we said it was 5. Okay, so it's going to be half. 15 plus 10, it's 150 times 5. I'll continue it from the top here. Okay, so 2 here 1, 2 into 150, it's 75. So it's going to be 75 times 5. Okay, so 5 times 5 is 25. 5 carry 2. 5 times 7 is 35 plus 2, 37. Okay, so it is 375. If I done my calculations properly, half A plus B H. So half A is 0 to 15 plus B 0 to 10. Height, oh, again, I've made a mistake on height. It's supposed to be 2. Okay, so here it's supposed to be 2, right? Okay, let me just redo it. Okay, I'll start from here. Half A plus B H. Half A it's 15 plus B is 10. H it's 5. Okay, so it's going to be half. 15 plus 10, 25. This is where I'd made a mistake, 5. Okay, so it's going to be half. 25 times 5, it's 75, right? 25 times 5, is it not 75? Oh, it's 125. 125. Okay, so 125, 2 here, 1, 2 into 12, 6. 2 into 5, it's 2. Remainder 1 point. 2 into 1, it can't. You put a 0. 2 into 10, 5. 62.5 meters is the second distance that was covered. So the total distance covered is going to be the first distance we calculated, which was 75 meters. We add it to 62.5 meters. Okay, it will give us 137.5 meters. Okay, so let me just add these two. So we have 75 meters plus 62.5 meters. So you can add them like this: 75 meters plus 62.5 meters. Okay, so yeah, the point you just bring it direct. 5 comes here. 5 plus 2, 7. 7 plus 6, 13. Okay, so it's 137.5 meters. Last question, find the average speed. So average speed, won't even waste time there. Average speed is total distance over total time. So what's the total distance? Total distance of calculated that it's 137.5. Total time is 15 seconds. Okay, so when you calculate here, you're going to 15 into 137, it's 9, remainder 1 over 6. Okay, so meters per second. If you want, you can write it as a decimal. I've just run out of energy to do that. Anyway, in case you're interested, 1 over 6, 6 into 1, 0 point. You add a 0 there. 6 into 10, 1, remainder 4. Okay, 6 into 4, you can't, so you add a 0 there. Okay, 6 into 40, so it's going to be 6 into 40, it's about 6. So it's going to be some long number, 0.1 something. So it's okay. I'll leave it like this. And paper 1, working with points is difficult. So you should tend to leave some as fractions. It's okay. They are the same numbers. Finally, question 4. Find the acceleration in the first 10 seconds. So the first 10 seconds, just this part. So acceleration is simple. Acceleration is v minus u over t. So what's the final velocity is 20 minus initial velocity 0 time it's 10. So it's going to be 20 over 10, which is 2 meters per second squared. Okay, so acceleration is 2 meters per second squared. B, find the acceleration in the last 5 seconds. Here, acceleration in the last 5 seconds. Acceleration v minus u over t. So final velocity 15 minus initial velocity 10. Time from here to here, it's 5. So 15 minus 10, it's 5 over 5. 5 divided by 5, it will give you 1 meters per second squared. So acceleration will be equal to 1 meters per second squared. C, find the total distance covered. Total distance, what shapes do we have here? So I can see a triangle here, and I can see also the trapezium here that has been rotated. So I'll start with the triangle. So this triangle has got B from here to here. 10 minus 0 is 10. And it has H from here to here, which is 20, and 0. 20 minus 0, 20. So distance is equal to area, which is equal to half BH, which is equal to half. The B is 10, the H is 20. So 2 here 1, 2 here 5. 5 times 20, it's 100. So the first distance, it's 100 meters. We go to the second distance. Okay, so the second distance is this shape here. Okay, so here we have A, which is from here to here. 30 minus 0, so it's 30. Then we also have B, B from here to here, which is 20 minus 0, 20. We also have the height, which is from here to here. 15 minus 10, it's 5. Remember, this has been rotated. It's supposed to be like this. Okay, hope you can see. So it's supposed to be like this. Okay, so A is the one on the bottom here, B is here, H is here. Okay, h is the one that is opposite to this side that is slanting. Okay, so with that we can take it back. Okay, so the formula, we know distance for the trapezium, we use half a plus b h. So it's half, what is a? A is 30, what is b? B is 20, what is h? H is 5. So it's going to be half 30 plus 20, it's 55. Okay, 2 here, 1, 2 into 50 is 25. Okay, so distance, okay, we 25 times 5, we're going to, so 25 times 5, it's 125. So it's going to be 125 meters. So this 125 meters, we're going to add it to the first distance we found, which was the 100 meters, and it will give us total distance. Total distance as 100 plus 125 meters, which is going to be 225 meters. Finally, find average speed. So average speed is equal to total distance over total time. Total distance, we know it's 225, right? Total time is 15. Okay, so next we divide 15 by 225. Okay, so let's just do it from here. We have 225, we have 15. So we can say does 15 go into 225? Okay, okay, if we're not sure, we can start with 5. 5 into 15, 3. 5 into 22, 7. Remainder 1. 5 into 15, it's 3. Okay, does 3 go into 7? 3? It doesn't. So 3 into 7, it's going to be there 2. Remainder 1. 2 into 13, it's there 4. Remainder 1 over 3. Okay, meters per second. That's the average speed. Okay, I think I'm tired, so I keep on making mistakes. So let's redo the calculations here. I think there is a mistake. Okay, so it's 225 divided by 15. Okay, yes, 15 here, 115 here, it's going to be direct, but I just wanted to show if you're not sure. So the number that goes into 15 and 225, it's 5. 5 into 15 is 3. 5 into 22, it's 4. Remainder 2. 5 into 25, it's 5. Okay, does 3 go into 45? Yes, 3 here, 1. 3 into 4, 1. Remainder 1. 3 into 15, 5. Okay, remember 15 times 15 is 225. Yeah, I wanted to show this for those who may not be good with dividing and all.